In this lesson, we're going to learn about the rhombus. So the definition of a rhombus is it's a parallelogram with four congruent sides. So the biggest difference between a parallelogram and a rhombus is that all four sides have to be congruent in a rhombus. Remember that a rhombus is a parallelogram, so it inherits all of those parallelogram properties. But in addition to those parallelogram properties, we also have two new properties, that a rhombus has perpendicular diagonals and diagonals that bisect the opposite angles. So when you look at this picture here, the diagonals of this rhombus, all four of these angles are going to be right angles because those are going to be perpendicular. And the diagonals are bisecting the opposite angles, so meaning these two parts are being congruent. And since a rhombus is a parallelogram, opposite angles are congruent, so really all four of these sections have to be equal to each other. And then if you look at this diagonal, these two parts would have to be equal to those two parts as well, because the diagonal is going to bisect the opposite angles, and since the opposite angles are congruent because it's a parallelogram, that means that these four parts are equal and these four parts over here are equal. Not all of the pieces are equal, just the parts of the opposite angles are going to be congruent. So let's look at some examples using these properties, and then we'll look at a coordinate proof of a rhombus. So the first example here, find the perimeter of a rhombus with diagonals that are 12 and 18 inches. So let's go ahead and sketch a picture like we always do. So the diagonals are 12, so this whole thing is 12, and then this whole thing is going to be 18. We know that these are perpendicular. I also know that they're being bisected. So instead of labeling this whole thing as 12, I'm going to label this as 6 and 6, because those two parts have to be congruent. Because remember, a rhombus is a parallelogram, so it's inheriting all of those parallelogram properties where the diagonals bisect each other. And then if this whole thing is 18, well, that means each part's going to be 9 and 9. If I want to know the perimeter, I have to know all four sides. And in a rhombus, all four sides are equal. So if I can find one of these sides, so let's say I want to find side X, then I can just multiply that by 4, and that'll give me the perimeter. So if you look at this triangle right here, you see that you have a right triangle. So hopefully you're thinking Pythagorean theorem as a way to solve for X. Remember, anytime we have a right triangle, we're thinking Pythagorean theorem to find a missing side, or SOHCAHTOA, right triangle trig. But in this case, we have two sides, so we're going to use Pythagorean theorem. So we're going to plug in. So 6 squared plus 9 squared equals x squared. So I'm going to go ahead and type that whole thing in my calculator. So 6 squared plus 9 squared gives me 117. And then if I square root both sides, I'm going to break this down. So if I divide that by 9, so 9 and 13. So when I divide it by 9, I get 13. So that means x is going to equal 3 root 13. So one of these sides is 3 root 13. So if I'm trying to find the perimeter, well, that means I'm going to add all of these together. So the perimeter means add all sides. Or you could say 4 times 3 root 13. So 4 times 3 root 13. Remember, when you're dealing with radicals, you can only combine these if they're like radicals. So I could do 3 plus 3 plus 3 plus 3. And that's how many roots I have. Or I could just do 4 times 3, which is 12. So I have 12 roots of 13. So that would be my perimeter. And remember, if you're ever unsure, type in the decimal for this. Make sure it matches, just to double check. The next problem here, we have rhombus ABCD. So again, I'm going to sketch a picture. So ABCD. The diagonals are intersecting at E. And it says DAC. So DAC is 18. I want to find the measure of ABC. So I want to find this angle right here. So the first thing that I'm thinking of when I'm doing this is the fact that since a rhombus is a parallelogram, these opposite sides are parallel. So I have the Z shape, the alternate interior angles. So if this is 18, up top here's got to be 18. I also know that since this is a rhombus, the diagonals are perpendicular, so I have right angles. And then I can easily find this part of the angle. So I can say 18 plus 90 plus x equals 180 and solve. So I can do that, and I end up with 72. So basically just subtract those off of 180. So this is 72, and if you remember in a rhombus, the diagonals bisect the opposite angles. So that means if this part's 72, well, this part here also is 72. These two parts have to be equal. So that means if I'm trying to find the measure of angle ABC, I'm going to add together the two 72s that I found. So 72 times 2 gives me 144. And remember, this isn't the only way to do this, but that's just the way that I came up with while doing it, looking at the properties. So the next example is going to lead us into our coordinate proof, and this is just asking us, so if we have a quadrilateral that's a parallelogram and it has two consecutive sides that are congruent, is that enough to prove it's a rhombus? So let's take a look at that. So if I have this figure here, and I know that it's a parallelogram, and I know that these two sides here are congruent. So those are consecutive, they're in a row. Well, if you think about a parallelogram, opposite sides are congruent. So this side and this side would have to be congruent. And this side and the opposite side to that has to be congruent. So therefore, all four sides end up being congruent, making it a rhombus. So the answer to this is yes, because both pairs of opposite sides are congruent in a parallelogram. So if two consecutive sides are congruent, then all four sides must also be congruent. And if that didn't make sense, think of it with numbers. If these two sides were both 5, well, opposite sides are congruent, so those two sides are 5. These two sides are 5, therefore all four are equal to 5, making it a rhombus. So then with that idea, how you can prove a rhombus, one of them is doing what we just talked about. So one of them is this method right here. Show you have a parallelogram with two congruent consecutive sides. That would guarantee it's a rhombus. So instead of showing all four sides are congruent, you could first prove you have a parallelogram by showing opposite sides are parallel, diagonals bisect each other, any of those properties, and then show that the two adjacent sides are congruent. That would work. You could also show that you have a parallelogram with perpendicular diagonals. So any method to get a parallelogram, and then the additional property is the perpendicular diagonals. Or use the definition. So this is probably your most common way to do the coordinate proof. Just use the definition of a rhombus. Well, a rhombus is a quadrilateral with 4 congruent sides. So that's the way I'm going to show you, because that's the one that most people remember the easiest, because you just show that there's 4 congruent sides. So if I'm going to show 4 congruent sides, that means I'm going to be using distance formula. So I'm going to write down the distance formula here. And I have to do it on all 4 sides. So let's go ahead and just sketch a picture so we can keep track of this as we're going. So I have A, 2, 4, 5, -2. There's B. C is 9, so 1, 2, 4, 6, 8, 9, up 1. And again, make sure you're labeling these as you're doing it. So that you remember. This should look like a rhombus. In this case, it's looking more like a square, which is okay because a square is a rhombus. So this might end up being a square, but I only have to prove that all 4 sides are congruent. I don't really care if it's a square for this particular problem. So what I'm going to do is I'm going to find the length of each of these. So I'm going to start off with AB, so the distance between those points. So remember, you're subtracting the x's, so the x's get paired. So 5 minus 2 squared plus, subtract the y's, negative 2 minus 2. So I end up with 3 squared plus, this is going to give me negative 4 squared. So I end up with 9 plus 16, so square root of 25, which ends up giving me 5. So AB is equal to 5. So now I'm going to continue this, and we should be getting 5 for all of these. So BC, start with our x's. So 9 minus 5. Then I have my y's. So 1 minus negative 2. And again, I'm seeing that these numbers are the same. Some are negative, some are positive, but when you square them, you'll get the same thing. So that's good. It means I'm on the right track. Remember, when you square these, you should never have negatives anymore. And these should match up, the numbers underneath. Otherwise, stop and figure out where you went wrong so that you don't have to finish it and then go back and fix it. So then I'm going to move on to CD. So I have 6 minus 9, 5 minus 1. So I'm getting negative 3 squared plus 4 squared. So 9 plus 16, again, square root of 25, so I get 5. And then we'll finish up with the last one here. So I have 5, and then over here I need to find AD. So 6 minus 2, 5 minus 2. So again, I have 4 and I have 3. Squaring those is going to give me the same numbers. So I get square root of 25, which reduces down to 5. So therefore, all 4 sides are congruent, making this a rhombus. So now I can write my conclusion, which is to say basically what you're trying to prove. So quad ABCD is a rhombus because all 4 sides are congruent. So that's it. That's your explanation. As long as you have 4 congruent sides, it's a rhombus. So go ahead and complete the check your understanding problems, and we'll do more with these coordinate proofs in class tomorrow and talk more about the properties in class.